Okay, today we're going to work on multiplying and dividing with roots or radicals, however you would call them. So the first one we're going to do is we're going to talk about multiplying. And so we're going to still use a box like we've been doing. It's just now we're going to have radicals or roots in them. So we're going to start off by drawing a box. And remember, for multiplying, you're going to put your information on the outside of the box. So we have a 5 and a square root of 6. And then we have a 2 and a negative square root of 6. Now, over here to the side, here's a few things that you have to know about when you're multiplying radicals. So whenever we're multiplying radicals, put a few things over here to the side. Okay, when you're multiplying radicals, you can multiply outside numbers together. You can multiply numbers that are inside the root together. If you have a number that's on the outside and the inside, do not multiply together. Okay, so do not multiply together. So do not multiply together. All you can do is write them next to each other. So for example, what I mean is if I'm going to take a 2 and I'm going to multiply it by a square root of 3, then I'm just going to write both of them down, but I'm not going to keep the times symbol in between them, so I would just write it as 2 and then square root of 3 right next to it. So I would just attach them together. Boom. And then the last thing we have to remember about these is we need to keep an eye out for perfect squares. So, you know, like square root of 4 is 2, or square root of 81 is 9, etc. Things like that we need to keep an eye out for. Okay, so let's go back and try working out our question. So 2 and 5, those are numbers that don't have any square roots with them, so we are allowed to multiply those together, which would make 10. 2 times the square root of 6, that would be like the one we're talking about over here in red, where you have one that's outside and one that's inside. So you're just going to write those down next to each other. So you would call it 2 square root of 6. 5 times negative square root of 6. Well, I have a 5, and on the outside of the root I have a negative. So I can put the 5 and the negative together. So I can call that negative 5. And then I just have to keep the square root of 6 attached to it. So I was able to multiply the 5 and the negative together because they were outside the root, and then I had to keep the root attached to it. And then the last box, the only thing outside the root is a negative, so I have to keep that. And then inside each root, I have a 6, so I can do 6 times 6 and call that square root. Sorry, my pen just went a little crazy there. So we'll call that square root of 36. Okay, so now I'm going to look down here like we talked about on this last one, and I'm going to notice I have a perfect square in this last box here. I have the square root of 36, and I know the square root of 36 is just 6, and I have to keep the negative in front of it. So this last box will really just equal -6 because that's a perfect square. So now what I'm going to do is I'm going to look for like terms. And like terms, I have plane number 10 and 6. So I'm going to take 10 minus 6, which will give me 4. And then remember in our last lesson, we talked about if you had roots, they both had to be the same index. So I have a square root, and they have to have the same number underneath, 6, 6. So these are indeed like terms. So I'm going to take 2 square root of 6 minus 5 square root of 6. So your outside number, 2 minus 5, is -3, and then keep square root of 6 attached. So then my final answer is 4 minus 3 square root of 6. Okay, and it's preferred that you write your plane number first and then your radical second. And you're done. Okay, your second example is going to move into division. And with division, if you could remember all the way back from first semester, we talked about division and we had I's. Kind of the same thing here. With division, okay, you need to know that there should be no radicals, so no roots in the denominator. And I'll abbreviate denominator. So no roots should be in the bottom of your answer, period. You can have roots on the top, that's completely fine, but there should be no roots in the bottom. Boom. So to achieve this, we talked about first semester, then you have to multiply the entire fraction by the conjugate. And if you don't remember what the conjugate was, we said you look at the bottom, so the denominator, and all you do is change the middle sign. So you will multiply the top and the bottom by, you look at the bottom, keep that information the same, except for the middle sign. You just change it from a positive to a negative, etc. So for example, let's say on the bottom I had 1 plus the square root of 15. Then you would multiply by 1 minus the square root of 15, and 1 minus. So you would take the entire fraction and multiply it by 1 minus the square root of 15. So I kept the 1 and the square root of 15 the same. The only thing I did was change the middle sign from a plus to a minus. And then, of course, the very last thing that you must always remember to do when you have a fraction is reduce if possible. Okay, so let's go try some. So over here, so remember, look at the bottom. Only thing you do is change the middle sign. So 2 minus the square root of 3, 2 minus the square root of 3. So if I'm looking at the top, I'm thinking I'm going to take 5 square root of 11 and I'm going to multiply that by 2 minus the square root of 3. So if I'm going to do that for the top, that means I'm going to use distributive property, because there is no plus or minus in between the 5 square root of 11, so that's considered one term. So here, when I take 5 square root of 11 times 2, I can take the 5 times the 2 because they're both on the outside, and that will make it 10, and then keep square root of 11 attached. And then when I come over here, I'm going to take 5 times negative, which makes negative 5. And then square root of 11 times square root of 3 is going to be square root of, and then 3 times 11 is 33. Now on the bottom, you have 2 items times 2 items, so that's going to be a box. So down here somewhere, I'm going to make a box. And so I'm going to have 2 square root of 3, 2, and a negative square root of 3. So then 2 times 2 is 4. 2 times square root of 3, well, those I'm just going to write next to each other. 2 times negative square root of 3 would be negative 2 square root of 3. And then negative square root of 3 times positive square root of 3 would be negative, and then I get to multiply the 3's together because they're both underneath. So that would make negative square root of 9. Okay, when I'm looking, I notice I have a negative 2 square root of 3 and a positive 2 square root of 3, so they should cancel. Then you should have a perfect square here, and the square root of 9 is 3, and since I have a negative in front of that, that will be negative 3. So then when you look at your like terms, you have 4 minus 3, which 4 minus 3 is 1. And remember, we talked about there should be no radicals in the denominator. So your denominator should get down to just a single number. You should only have one number on the bottom, no roots at all. Do I really have to write this over 1? No, I don't have to write it over 1. And because the bottom number is 1, I don't have to reduce. So this one is finished. Okay, let's try the next one. Okay, for this one, I'm going to multiply by 5 plus square root of 7. And on this one, I'm going to have to make a box for the top, because you will notice that there is a plus sign between the 3 and the square root of 7. So this is considered 2 terms times 2 terms. So it's not like the first one where I get to use distributive property. So this one I will have to make a box. So I'm going to make a box for the top. So 3 square root of 7, and then 5 square root of 7. So 15, and then write them next to each other. Write them next to each other, and then keep the square root and multiply them together and write it underneath the square root. And then you'll notice, ooh, the square root of 49 is a perfect square, which is 7. And then here I have some like terms, so I can combine 15 and 7 together, which gives me 22. And then I can also combine 5 square root of 7 plus 3 square root of 7, which gives me 8 square root of 7. So then on the top, you should have 22 plus 8 square root of 7. So now I'm going to make a box for the bottom. And I'm going to have 5 negative square root of 7, 5 positive square root of 7. So 25, and then negative 5 square root of 7, positive 5 square root of 7, and then negative square root of 49. Positive 5 square root of 7 and negative 5 square root of 7 cancel. Perfect square in the last box, and square root of 49 is 7, and keep your negative, so that's negative 7. So you're looking at 25 minus 7. And 25 minus 7 is 18. And so that means your bottom is going to be 18. Oh, hold on. I forgot my square root symbol over here. Whoopsie. Let me go back here and erase this top. I put 87 instead of 8 square root of 7. Sorry about that. There we go. Okay. Now remember, we're going to look to reduce, and when we reduce, you reduce all the numbers that are not inside of a root. Okay, so we're looking at the 22, the 18, and the 8. All of the numbers that are not inside of a root. They are all divisible by 2. So then your final answer should be 11 plus 4 square root of 7 all over 9. When you're reducing, you should never change the number inside of the root. Okay, that's it. You're done.